Alright, cool kids. You guys kind of figure out where your questions were on the odds if you had questions on the odds? We'll see, huh? Are there any odds right now that we can circle though? Any ones for sure that we already know? We're okay on the odds? Huh? I think we did.
49.
49. Anything else that we already know from the odds? 9? Okay. We'll get back to that in just 1 second. Let's go ahead and grade our evens. Colored pens out. Spirals open. Here we go. Now guys, remember, when I check your spirals, I need to see the grading happening. And if it's not happening, I have to take off points for each homework that it's not happening in. So if for any reason you don't have it ready during class time, you're going to have to go to the video and you're going to have to grade it yourself later. Are we all tracking? Okay. Here we go. Number 2. Final answer. Vertical asymptote. Number 8. Was that a removable discontinuity? No, non-removable. Number 8. Now guys, ew, gross. They're using tables. Did you have to use a table?
No.
If they didn't say you had to use a table, couldn't you have used our cool shortcut? Do you remember what our cool shortcut is from yesterday? Do you have to plug in all these numbers to figure out what's going on from the left?
No.
No, you only have to plug in
One.
one of them. And then, Ricky, what are we supposed to check when we plug it in?
The sign.
And the sign should have been?
Negative.
So the answer, as x approaches -2, oh, look at all these words they're using. Oh, that's ridiculous. Didn't we have cool notation we can use instead? What is that notation? As x approaches to negative. What does this mean? All those words we're saving ourselves. We're really just saving ourselves time by learning this advanced notation. And then where is f of x going?
Negative.
Got it. Look, you saved yourself a whole paragraph. We technically have to do the other one as well. And then as x approaches to positive from the right, f of x is approaching. Remember, did you have to plug in all these numbers from the right? No. All you had to do was plug in one of them and check the sign, which was a positive. Hence f of x is increasing without bound, or it's going to be positive. So once again, I suppose you could be writing down huge tables and writing huge paragraphs. Okay, I'm being dramatic, but still, doesn't this look a whole lot easier?
Yeah.
Okay, so be using it, okay? Number next one. You are also having to approach another vertical asymptote. I think from the very beginning you had vertical asymptotes at -2 and +2. So for -2 from the left, you're going to negative infinity. The function's going to negative infinity. From the right, function's going to positive infinity. As you come towards 2, don't do all of these, do 1. Check the sign. As you come towards +2 from the left, f of x is going to negative infinity. As you approach +2 from the right, f of x, that's a positive number, is going to positive infinity. But you guys just saw the notation. I don't think you need to write it all over again. Okay, number 12. Domain. Set the denominator, only the denominator equal to 0. And you get -3/2. Why is it a vertical asymptote? Why not a whole? You can't factor, you can't cancel. Just if you might be like, but, look, if these go away and the x's go away and the, okay, -7/2. What did you just kill?
A lot of things. One of the things.
Yeah. Kittens die every time you start randomly crossing off stuff and not factoring. Factoring.
So sad.
Cross off stuff.
Well, if I hate kittens,
If you hate your math group, you could.
Oh, I was going to say that.
doesn't matter.
Just for this time. Group the top, group the bottom. They don't match. You can't go cancel instead. Oh, that was take 2. Struggle. Horizontal asymptote. Remind me, how do we solve for it?
The coefficients of the
Coefficients of the degrees, like the highest terms, as long as only if they are equal. They're tied. Good. If they're equal at their times. So since there is a tie, racial being coefficients. Remember, vertical asymptote x equals horizontal asymptote y equals. Number next one, 22. They put it funny. They say all real numbers, x except x equals 1. I just say x doesn't equal 1, right? That's my shortcut. X doesn't equal 1, indicating x can be anything else. X-intercept. You guys had to plug and chug for this. I'm not going to take a lot of time on this because we did a big example yesterday. If you were gone yesterday, go watch the video. We did one big example, kind of like 22. X-intercept, 1/3, comma 0. Y-intercept, 0, comma 1. Vertical asymptote at x equals 1. Horizontal asymptote at y equals 3. There should be some work for this, especially the intercepts. Maybe not the rest, but the intercepts. Wait a minute, there's a table. I told you guys specifically not to do the table. Ooh, so if I did spot check and started seeing tables, what do I know?
Didn't pay attention.
You weren't really doing what I asked you to do, and you were just doing it the calc chat way, which isn't always bad. But if I tell you not to do something, hopefully you follow the direction. What did I ask you to do instead? So we need to check what you did, right? Good. Describe the behavior near the vertical asymptote. So then, we should say, as x approaches, who's the vertical asymptote? 1. From below and from above, we're answering the question, what does f of x do? And what does f of x do? What did you guys get? As you come towards 1 from below? Negative infinity, good. And as you come towards 1 from above, positive infinity. How would you have done that? Let's see, a number from below, 0.9. A number from above, 1.1. Check the sign. Once again, if you're a little stuck on that, go back to yesterday. We did this in detail. Watch that video. Watch that example we did at the beginning. Do you guys see how we didn't really need all these points? If you graph the intercept, you know what's going down, you know what's going up. Swoop, swoop, we're done. What? No? Anyway. 42, 43, 44, you guys see how they look funny, right? Why they look funny? Because the book was all off. Who knows what they were doing? They were like putting in numbers as answers or letters as answers that weren't even options. These are the correct answers for 42 through 44. I think 43 might have even been wrong if you did check it like in the back. Should have been A, then C, then B. Scooching down real fast. Number 60. Here's another one. Just like that big honking example we did yesterday. You guys can go ahead and see A and B and C. I'm going to quickly show what I was asking you to do for D. Really, who wants to find those fractions anyway, right? I didn't. Find the behavior near the vertical asymptote, we would say as x approaches 2 from below, as x approaches 2 from above. I would have plugged in 1.9. You could have done it there, or you could have done it here. 1.9 here would make a negative number. Negative kind of small number. 1.9, oh, that might be hard to plug in, huh? They did long division to simplify. Didn't really help much. I think I technically, in factoring and simplify, would have stayed right there. I probably would have stayed right there. But when we go to plug and chug 1.9, you might have actually wanted to use your calculator for this one. But you would have eventually gotten, as you come towards 2 from below, negative infinity. As you come from 2 from above, plugging in 2.1, probably with the calculator again. It doesn't factor this. There we go, there we go. Rookie, what's your question, Ben?
I did all the wrong problems. I think I did the problem for section 2-7.
Okay, here's what I need you to do. I need you to go ahead and take the 2 assignments tonight and match up. Because it happens every now and then on accident. And when like everything's off, I know that you did on accident. So go ahead and compare the 2, and basically I just need to make sure that you did like a problem in each of the sections I asked for. Does that make sense?
Yeah.
And if it's like 2.7 has 10 problems and 2.6 has like 15, then just kind of find the sections that you should have done a few more and pick out a few of those in there. Is that cool?
Yeah.
Thanks for letting me know. If you guys notice though, what's missing from letter B? It said find the intercepts. Plural. Why is it missing? there isn't one. It doesn't hit. And if you were to try to find one, long story short, you can't factor the top. So when you went to set everything equal to 0, it wouldn't have worked if you had gone with the traditional route of, can't factor. How do I find the zeros? X equals negative b plus 9 squared, b squared minus 4ac. Got it. 25 minus 40 is a negative number. That would be imaginary, which means you can't see it on a graph, so we say none. None for what? None for x-intercepts. That was the funniness of this one. So in case you're checking, it's not there because it didn't exist. And when you go to show the graph, hopefully you kind of see that. It never crosses because the slanting asymptote and the vertical asymptote, they squeeze it in and there's no way it's getting up there. It's not going to work. Number last one. True, true, false. True, true, false. It was a little weird. But if the denominator is 0 and can't factor out, then there is a vertical asymptote. Letter B is true because if the degrees are tied, then you get a horizontal asymptote at a number. So since you had a horizontal asymptote at a number, the degrees had to be tied. But letter C, if the degrees are tied and if the horizontal asymptote is 2, the ratio of the leading coefficients better be 2 and not 1. Remember, the ratio of the leading coefficients, can I hit that? No. The ratio of the leading coefficients make the horizontal asymptote, so they need to match. They said 1, nah, it's not at 1. It has to be at 2. That's what the graph shows. All right, cool kids, with that, we can't take a lot of time. And some of these problems are really long, but let's just see what questions we had. I know that you guys had 9 and 49, is that right? 9 and 49. Any other ones going once? Any other ones going once? All right, that's it. Do I have 2 volunteers for participation 949?
I'll do 9. Actually, did that one.
Justin, which one do you want? Hold on. 9? 49. All right, hey, I have both. Anybody else want to steal it from Ricky though? Because he's gotten one before. Ah, stolen. Come on up and grab a marker. You guys can come up to the front board. Yeah. Just not to go right beside her. Sign your name at the end so you make sure you got enough data points. Alright, the rest of you guys, you can check out 9 and 49. But if you either A, don't need it, or B, need to let them get a little bit further into it before it'll help, let's go ahead and get the next example in our notes. That's a yes. Let's go single page. Emily, do you have your phone? Do you have your phone? Oh, okay. I was going to say you could take pictures of the notes and then be writing them. Or if you want to borrow someone's notes real quick, that'll help you to catch up. If anybody else was absent yesterday and you're like, I didn't get to make up notes, you can borrow someone's notes real quick and be catching up. That might help you. But otherwise, the rest of you guys, here's the next example. If anyone else was absent yesterday, you can make up notes and borrow from somebody else who takes their notes. Otherwise, took me a few years to get that one. I'm going to pause the video. A nastier, a more difficult example, but the steps are the same. You guys have the steps a little bit up in your notes. Step number 1 says, find the who? Key numbers. But I don't have a polynomial. I have a rational function. You could look off to the side in your notes. For rational functions, who are the key numbers again? The zeros and the undefined points. The zeros and the undefined points. Now, when we wrote about the key numbers, which was actually above the steps, for rational functions, I gave you guys a little pitchforky thing. Did you see that? The f of x over g of x, you drew a little pitchfork. The zeros Set the top equal to 0, it's a 0. Set the bottom equal to 0, it's undefined. But looking at that pitchfork, wasn't that only when it was solved for 0? What's this one solved for? Ah, the 3 doesn't belong. I'm going to show you the pitchforky thing in just a little bit. But first of all, question. How would you guys normally try to solve this? What would you do? Yeah, let's do the old-fashioned way, okay? The old-fashioned way, you'd say, hey, let's move that x minus 5 to the other side. You would get 2x minus 7 is less than or equal to 3 times x minus 5. Does that make sense? Multiply to the other side, x minus 5. Then we would get 2x minus 7 less than or equal to 3x minus 15. Then we would keep solving. Subtracting the 3x, we would get negative x. Adding the 7, I know I'm doing some algebra fast, but I'm just solving algebra. I'm moving stuff. Subtracted an x to the left, moved a constant to the right, etc., etc. What happens when I flip the inequality? That's what you think the answer is. You're like, oh, sweet, I'm done. X greater than or equal to 8. Ooh, yeah. That's only half the answer. Wait, that was easy. Like, no big deal. We solved it, right? Sad times, it's only half the answer. Cabling, are we not half on those? No, it's okay. Oh, Tyler's using it. X is greater than or equal to 8. It's only half the answer. So what if, instead of having the inequalities, if it doesn't actually solve for the answer anyway, do you remember how for zeros we just said equal to? Okay. So let's say we just said equal to, and equal to, and equal to. Yeah. Equal to. Now this isn't the answer, we know that. We have this whole inequality thing. We should have lots of answers. My question to you is 8 a 0, or is 8 an undefined point?
0.
Yeah, it didn't come from a denominator, right? Couldn't be undefined, so there has to be one of them. 8's a 0. Now here's the other question you have to ask yourselves. Okay, who's the undefined one? Don't look here. Look here. Who makes this whole thing undefined? Why? Why? The denominator. Remember, the denominator can't be 0. So set the denominator equal to 0 and say 5 is undefined. And solving it the easy old-fashioned way, that got 8. That's the 0. Now let me show you the other way, the new way. You would have to solve it in order to do the pitchforky trick. You would have to say, we need a 0 from the get-go. You do 2x minus 7 all over x minus 5, subtract the 3, and say, ha-ha, 0. But then you have to say, wait a minute. Now it's all messed up. I have 2 different pieces. So you'd have to go ahead and get a common denominator by multiplying the 3 by x minus 5 to be able to join the fractions together. I have to do a little x minus 5 over x minus 5. Then we could say they have common denominators and put them all together, so 3 over 1. And what would happen is, after you simplify, not killing any poor little seals, you would end up with negative x minus 8 all over x minus 5 is less than or equal to 0. Now that there's a 0, I can say, oh, hey, okay, take the top, that's x equals 8, and take the bottom, that's x equals 5. Does the pitchfork trick work? Yeah, but only if you have what on the other side? Okay. Now, here's the dilemma. If you do it the longer way, you see both ones, the 0 and the undefined, all at once. So you're like, okay, take one from the top, one from the bottom, got them. If you solve the easier, I'm confessing, right? I'm saying it like it is. The easier way. If you go the easier route, how many do you get? Just one. But how do you get the other one? Just steal them from the denominator. So it's going to be easy to only see one if you go this route. You have to steal the denominator from the beginning. You can go either way, and I don't care. But if you go this way, don't forget to find one from the denominator. If you go this way, be careful with the algebra.
What would the 8 be positive?
Oh, because when you solve, you would, hold on, my simplifying was wrong. I was doing it too fast. 2x minus 3x is a negative. Negative 7 plus 15 minus a negative, that'd be a positive 8. Thank you, Caleb. Thank you, Jason. Thank you, Tyler. Oh,
No.
you have a question?
No. What's in that really messy
Ah.
parentheses?
The really messy parentheses is me doing the following. Or is my doing the following? My grammarian. No grammar, it's math. No excuse. Let me make more space. I'm getting a common denominator, but that makes sense? Because 3 is over a 1, and I need to make it all common to put it together. Okay, long story short, whichever route you take, you can get to my key numbers. And what do we do with key numbers? Put them in a number line. Okay. We're past all the crazy. So put 5 in the number line, put 8 in the number line. Okay, hold on. Before we get to the table, where we ask ourselves true or false, am I going to have an open circle above 5 or a closed circle if 5 is an undefined point? Undefined, it can't even be there. What? The function can't be there, so he's always going to be open. Undefined points always open. They don't exist. How about 8? Why closed? Because it can be 3. It's a 0. It can equal 0 if we were to do it the wrong way. So since it's an or equal to, I close it at 8. Then I'm going to go ahead and get to a table. I'm going to ask myself true or false by plugging in for certain x values, and I'm making 3 spots. Why? I need a number from the left of 5. Give me something.
4.
How about 0? He's easy. 0's to the left, he's just way to the left. Something in between 5 and 8? 6? 7? You come for those decimals if you want. Something to the right of 8? 10? Something? I don't know. And then what would we do at this point? Plug it in, plug it in. Where? Each of the places. But what would we plug it into? Your choice. Either this one or this one. Either that one or that one. Now, not all of you are finding this one, so I'm going to plug it into that one. If we plug in 0, we'll get negative 7 over negative 5. Is that less than or equal to 3? 7 fifths, 1 and 2 fifths is less than 3. True. What would you guys need to do to finish? Plug in, true or false, and then you guys have honestly seen the bulk of 2-7. The homework isn't due until Monday, but my advice is tonight. The homework is not done. Homework is started. Bye guys, see you later. If you have questions, come after school. Bring your quiz, bring your homework questions, you get lunch. I don't need pictures for it.
What would make the name magic? Like that specific adjective.
It's what Disneyland employees legally have to say to the front desk.
Legally?
Yes.
So you're telling me
Yes.
that they're breaking law?
Yes, if they don't say that. Disney can fire them if they don't say